This is a demonstration of code for use with physical switches in an Arduino board. For our application, the code, switches, and board will be used as bumpers that, when hit by a pinball, automatically adds a set number of points to the player's score. In this demonstration, the board will send two different messages to the serial monitor depending on the state of the switch. The Metro Mini is plugged directly into the breadboard. The 5-volt and ground pins are set to power their respective rails. 5 volts feed into the common pin of the switch via the purple wire shown. The normally open pin is fed to two different components. One component is the 10K pull-down resistor, to which the other side is connected to ground. The other component is the Arduino's digital pin number 2. When the switch is pressed, power flows through it, sending a logic 1 or 5 volts to pin 2. When the switch is released, the pull-down resistor immediately brings a signal to a logic 0. The code could not run correctly without the use of the pull-down resistor. I'm going to demonstrate the circuit running without the pull-down resistor first. When the switch is pressed, all is well, as it is guaranteed value of logic 1. However, once the switch is let go, the output begins to write randomly. This is because the input is floating. What this means is that since the values are not coming in discretely, the value being read is uncertain. Therefore, the code begins to randomly return high or low as being shown here. When the pull-down resistor is introduced, it gives the pin a clear-cut input value of 0 when the switch is not being pressed by immediately grounding it. This allows the code to be certain that the switch is either on or off with no in between. And, as demonstrated, the switch now works perfectly.